This
Okay, guys. From yesterday class, we discussed about what is EIGRP, why do we need EIGRP in terms of advanced distance vector protocol. We talked about EIGRP neighborship conditions. We talked about EIGRP metric calculation with K1, K2, K3, K4, K5 values. We talked about matching bandwidth, delay, reliability, load and MTU. And we also talked about EIGRP best path, second best path with the successor and feasible successor paths. And also we talked about the reported distance, which is the neighbor advertisement distance to reach the destination. And then we talked about the feasible distance, which is the best distance to go to the destination. We have seen about EIGRP AD value being 90, which will be preferred over the OSPF. And today, let's start doing the EIGRP lab. Just like OSPF, we will do EIGRP neighborship between the peers. And we will make two networks communicate using EIGRP. So any questions before we start the lab?
No, sir.
Okay. Let's start the EIGRP lab. So again, from our lab, we will take a couple of PCs. We will put a couple of PCs here. We will take a switch. We're gonna connect these two PCs. We will do a route on a stick configuration. Similarly, we will connect these two PCs. Okay. And then we will connect between the router to router. For labeling purposes, we will do 10.0.0.10, 10.0.0.11, 20.0.0.10, 20.0.0.11. This is the gateway. 20.0.0.1, and this is the gateway. 10.0.0.1. Subnet, just like 55.55.55.0. The subnet, and then we will use Let's show this is building here. Let's pick this as VLAN 10. VLAN 10. Hello, VLAN 10. Let's pick VLAN 20. VLAN 20. Hello, VLAN 20. Let's make this as EIGRP link to connect two buildings. So we will, for EIGRP to become the neighbors have to be reachable. So we'll pick this interface as 30.0.0.1/3. And then let's pick this one as 30.0.0.2/30. Okay. And once we bring up the EIGRP neighborship, the PC in building A should be able to communicate with PCs in building B with the EIGRP neighborship. Any questions on the setup, guys? Just like a pretty basic setup that we did for OSPF, we have repeated the same for the EIGRP. Any questions, guys?
No, Ravi, no question.
Okay, all right. Let's go ahead and start configuring the IP addresses and then VLANs, trunking the VLANs and stuff like that. The very basics. Config. Go to the interface. Define 10.0.0.10, and then define the subnet 255.255.255.0. And then let's go ahead and define the default gateway, which is 10.0.0.1. Similarly here, Subnet is 252.253.0. Default gateway is 10.0.0.1. Okay, so this part is done. Let's go ahead and define the IP addresses of these PCs. And then go and find the IP address. Zero 11. Define the gateway 20.0.0.1. Define the gateway here as well. 20.0.1. So these four devices IP addresses and the default gateways are defined. Now let's go to the switches and define the VLANs and allow the trunk over the VLAN. CLI enable config terminal VLAN 10 building a VLAN, that's it. And then define these two ports in access port and with VLAN 10. /1, 0/2, interface FA 0/1, switch port mode access, switch port access VLAN 10. Similarly, interface FA 0/2, switch port mode access, switch port access VLAN 10. There is no MAC address here. The ports are still red. So those have to be up. And then let's use this as a trunk port FA 0/3. FA 0/3, switch port mode trunk, switch port trunk, allowed VLAN 10. Okay, so now let's check the access port. To check that, show VLAN space ID space 10, FA01 and FA02 are in the VLAN 10 in this VLAN. Then let's go ahead and define the router. And then we will define the gateway here with the subinterface .10. Okay. So on the router, I'm going to do enable config terminal interface gig 0/0/0. No shut. Then we will do interface gig 0/0/0.20. Oops, sorry. Interface gig 0/0/10. I mean, you can give 20, but we need 10, right? So I'm going to do no interface 0/0/0.20. I removed it. Okay, I'm going to do encapsulation .1Q10 as the VLAN tag that need to be allowed, and then define the IP address 10.0.0.1, 255.255.255.30. Okay. Show IP interface brief. We can do show MAC address table. Oh, sorry, show IPR because it's a router. Still not learning the ARP entry. So let's go ahead and here and then try to ping the gateway. Now it will generate the broadcast message. The ARP binding should be working. Okay. Okay, let's go ahead here. Desktop. Let's go ahead. Ping 10.0.0.1. Pinging the gateway. So let's go ahead and check the ARP now. Earlier the ARP was empty. If you check the ARP now, you should be seeing the ARP entries. You see the 10.0.0.10 and the MAC address is C811. So you can validate that by going here and then check the MAC address. Here, if you go ahead and then go to the physical, and then if you go to the interface, you will see the MAC address here. C811, 4115 C811, that should be matching here. 10.0.0.10 matches with the 4115 C811. So the connectivity between here to here is good. Now let's try to ping from here. That will also have the gateway connectivity. Okay, ping 10.0.0.1. And now if you look at the ARP entry, you should be seeing one more ARP entry, 10.0.0.11. So yeah. So now we have 10.0.0.10 and 10.0.0.11. It says 00AA. Let's validate that. Go ahead and go to the config. It says 00AA BA24. That should be matching with this one. BA2400AA. So now these PCs are able to communicate the gateway, but they will not be able to go outside of the gateway because the EIGRP neighborship, a dynamic routing or a static routing is not done yet. Let's try to ping the other gateway 20.0.0.1. It says it goes to 10.0.0.1 and says destination post unreachable, meaning it is trying to go to the gateway and from there is no route. It's not able to reachable. It says unreachable. Okay, so once this neighborship is learned and the route exists here on the router 0, then it should have a route to the building B. Any questions so far, guys? No. Okay, let's go ahead and go to the PC2 and PC3 on the building 2. Let's go ahead and try to ping the gateway. This is FA0/1, this is FA0/2. VLAN 20, name building B, interface FA0/1, switch port mode access, switch port access VLAN 20, interface FA0/2, switch port mode access, switch port access VLAN 20. And then we have to use this port as the trunk port, the uplink port. FA0/3. Switch port. Switch port mode trunk, switch port trunk allowed VLAN 20. Okay, I can check with show VLAN ID space 20. Yes, 0/1 and 0/2. Let's go ahead and go to the router and define the gateway here. I'm going to enable config terminal interface dig 0/0/0. No shut. Interface dig 0/0/0.20. Encapsulation.1Q20. IP address 20.0.0.1. And subnet is /24. And no shut. Okay. Same thing, once the link is up, we can check the ARP table here. This MAC address should be broadcasting, sorry, this PC has to be broadcasting to the switch. Switch will send that to the gateway because the trunk is allowed on the VLAN 20. The gateway gets it, it replies back, and you should be able to ping the gateway. So now if you observe, show IPR, ARP table is empty, and if you have observed the ARP here, desktop, ARP space -A, no ARP entry is found. Now let's try to ping the gateway, ping.20.0.0.1, screen reply. So now if you observe the ARP entry, you should be seeing the ARP entry of the gateway here. So it says 8401. So if you go here, if you do the show IPR, it's learning the ARP entry of the host. Okay, and the MAC address is 7379. If you go to the device, and if you observe the config, you go to the interface, it says 7379. So there is that. So now let's go ahead and here and then generate some pings. We are not seeing that. We can ping 20.0.0.1. Learning. You can also ping the other side of the PC. So this PC is learning the ARP entry, so you can check ARPs now. You'll see both the ARPs 20, which is the gateway IP, and the ARP entry of the other PC. Okay, so from the next time, if it goes, it will directly go to the PC directly. It will not go to the gateway. You can check that by doing the simulation. You can start the simulation. You can go here and then generate some pings. It will directly go from here to here, and the switch will directly send that packet to the PC2. It will never go to the gateway again because the switch knows the MAC address of both PC2 and PC3. It will directly switch the packets between them. It does not need to go to the gateway to talk between the PCs in the same VLAN. So they will be able to directly communicate between them. Okay. So now let's stop the real time. Now let's do the EIGRP neighborship between both the buildings. So for that, we need to configure these interfaces, give the interface IPs, and then let these interfaces reach each other, like the IP addresses, like 30.0.0.1 should be able to reach 30.0.0.2. So they should be able to reach between both of the routers. So let's do that first before we do the EIGRP. So let's see what is this interface. Conf interface gig 0/0/1 IP address 30.0.0.1 and /30 is 255.255.255.252 and then do no shut. Okay. This side we try to bring it up with the IP address and then doing no shut. Here also we will do the same. We'll bring up the interface with the IP address and no shut. Dig 0/0/1 IP address 30.0.0.2 255.255.255.252 no shut. Okay, so let's try to ping the from here. Let's try to ping the other side. Okay, so now go into here and then just do end ping 30.0.0.2. Okay, and ping again. It's pinging between both the routers, so it was successful. So now we have the connectivity between the routers. So now let's go ahead and define the EIGRP configuration. So before we do the EIGRP, let's look at the routing table. Show IP route. You will see only connected route, which is locally connected route, and you will see the other connected route, which is also the 30 network. Building A has 10 dot network and the connected 30 network. That's what you're seeing, 10 network and 30 network. If you observe building B, you will see you have 20 dot network and also 30 dot network. 20 network is belonged by building B and also it's connected between 30 dot network to the building A. So now building A should learn the 20 dot network and building B should learn the 10 dot network. Right? So because building A should be able to communicate with building B should be able to communicate with building A. So 10 dot network and 20 dot network should be learned both ways. Okay. Config terminal router EIGRP. We'll define the AS number. It can be any AS number. For example, if you do router EIGRP question mark, it will tell you can pick any of the number. I just picked one as my AS number. Okay. And then inside that you will define the networks that you own. So here on this building A, we own 10.0.0.0, 0.0.0.255 as the network, and also we own network 30.0.0.1, 0.0.0.3. Okay. So we can check show run pipe section EIGRP to only check the EIGRP. And also you don't want to do the auto summary. So if you don't want to do the auto summary means like it will be summarizing based on the subnet, like class A, class B, class C networks, it will be summarizing. If you don't want to do that, you can just do router EIGRP1, no auto summary. That way your routes are not summarized. They'll stay as is. It will not try to summarize them into the groups. Okay, here also we go to here. For EIGRP to become the neighbors, their EIGRP AS number should match. So router EIGRP1 and then network statement. Here we own 20 dot network, 20.0.0.0, 0.0.0.0.255. And also we own 30 network here, 30.0.0.2, 0.0.0.3. No auto summary. Okay. If you want to do the neighborship check, show IP EIGRP neighbor. Okay, so it says I have a EIGRP neighbor address 30.0.0.1. It's up from 11 seconds. is what it's saying. So you can check that it's up from 20 seconds. So here I can go to the router 1 and check the EIGRP neighbor, show IP EIGRP neighbor. EIGRP neighbor is up with 30.0.0.2. And earlier we checked the routes. Here we have seen 10 network and 30 network only. We did not see the 20 network route. But now because EIGRP neighbor is formed, we should be seeing a 20 network with the EIGRP route, meaning we will be seeing DEIGRP in the routing table. So let's check that. Show IP route. If you observe, we are seeing a 20 network that is learned via 30.0.0.2 46 seconds ago. It's a D route. D means EIGRP route. Okay. So now let's go ahead and then try to ping the earlier. We are trying to ping 20.0.0.1. It says destination host unreachable. Now let's try to ping it. It says it's getting response from, it's not unreachable anymore. It's getting response. Let's try to ping the actual host. It's also pinging. Let's ping the other host. It's also pinging. So with the help of the dynamic routing between these two routers, it knows all the networks of building A on this side. So by doing the EIGRP between router 1 and router 2 or router 0 and router 1, these networks are learned by this router and these networks are learned by this router, and they are able to make the routing between them. Okay. So this is how the connectivity works between the buildings with the help of a dynamic routing protocol like EIGRP or OSPF. Any questions, guys?
Uh, is this the same way as the GRP? The last class we discussed about the OSPF multiple routers, right? Is this the same procedure for this also?
Yeah, same process, no change.
Okay. I mean, with multiple routers, it would be the same process, right?
Yeah, same process.
Okay. Thank you.
Any more questions, guys? Okay, guys, if you don't have any questions, let's move on to the next topic. As we complete the EIGRP, OSPF, and also RIP, that completes the IP routing for the CCNA syllabus. We have to move to the IP services. So any questions on the routing, guys? Okay, let's start talking about the NAT concept. We will talk about what is NAT and why it is used, and what are the different types of NATs in the network. Let me start sharing my screen or whiteboard. So NAT stands for network address translation. It is process of changing the IP address from one IP to another IP. Basically, the main use case of NAT is to translate the private IP address to the public IP address concept. So meaning, let's say you are in your house and you have multiple devices in your house and you are connecting to your Wi-Fi router. So until this point, all of your communication will be with the private IPs inside your house between the devices before with the help of the router. But when you wanted to go out of the internet, outside of your home network, then you need to convert your private IP to the public IP. Private to the public IP. This is done by here with your router. It will convert your private IP addresses to the public IP addresses, right? So that is one use case of the NAT. Basically, conversion of an IP address to another IP is called network address translation. The use cases are translating from private to public and public to private is called the NAT concept. Okay. So why do we need, I mean, let's start talking about the use cases with different types of NATs. Okay. So there is a concept called static NAT. So what is static NAT? We'll see here in a second. Give me 1 minute. Okay, so we are talking about NAT, right? So we started talking about translating the private IP to the public IP. That is nothing but the network address translation or vice versa. So translating an IP to another IP is called the NAT. So let's see the use case of a static NAT, which is one of the basic NAT. That is the first kind of NAT or the basic NAT that we use. Let's say you own a small company or you're working for a company. Okay, let's say you're working for a company and that company is hosting a web server. Let's say you guys are doing the roofing to the houses. Okay, roofinghouses.com is your company website. So this is like a web server, right? So in your company, you will have a web server that is hosting this web page. This is a web server. This web server will have a private IP inside your company. But there are people all over the world, all over the country, whoever want to get their roofs done to their houses, they will try to hit your website, which is nothing but they are trying to hit your web server. But they cannot access your private IP because these are all from the internet, right? These are all users are spread across the internet. When I mean internet, they can be living in any location. They are not part of your company. They're spread across different They are spread across different locations, right, or regions like that. So now what you have to do is you have to put a router or a firewall that will be able to convert this private IP to the public IP. So users, what they will do, they will hit this public IP. Let's say the public IP for the roofinghouses.com is 38.38.38.38, and your local private IP is 10.0.0.38. Okay, so now user is all these users are trying to hit the public IP 38.38.38.38. It's getting translated to this private IP 10.0.0.38. So this is a static NATing. So you have one public IP, and that one public IP is mapped to one private IP. So all the users will hit this public IP. The public IP will be translated and point them to the internal private IP. This is the static NAT. It will translate one public IP to one private IP, or one private IP to one public IP. So here in this case, the public IP will always, be this IP. Users will start hitting this IP, and they will be translated to the private IP. That is the concept of static NAT. Any questions about static NAT, guys?
No, sir.
Okay. Next, let's talk about the dynamic NAT. Okay. Let's say here also you're owning a company called roofhousing.com. In your company, there are a lot of users, right? Employees. Let's say you have, for example, 5 employees. Okay, employee 1, employee 2, employee 3, employee 4, and then employee 5. Okay, you have 5 employees, just for an example, and all of these employees wants to reach out to the internet. Okay, so now, like the earlier use case we talked about, you will have a router. All of these employees will be connecting to a router. Okay, so they will be connected to a internal router, and this router will be sending the traffic to the internet. Okay, so here you have one public IP, and then you have second public IP. So what you thought was, instead of using one public IP, you wanted, let's say, employee 1 and employee 2 wanted to hit one public IP, and remaining 3 employees wanted to hit the another public IP, because you wanted to see the separation. Let's say these first 2 employees are the management, and the other 3 employees are from the core team. Okay, so you wanted to see what management is trying to do when they are trying to go to the internet, and what core team is doing when they are trying to go to the internet. So you are changing their public IP so that you can track what traffic is coming to the router, and then what IP they are mapping to the public IP and going to the internet. So you are creating a pool of public IPs. So you have a pool of public IPs. You have a pool of public IPs. So half of the users will be pointing to public IP 1, and another half of users are pointing to the public IP 2. That is nothing but the dynamic IP. So private IP addresses are mapped to pool of public IP addresses. So inside that pool, some private IPs can be mapped to one public IP and another private IPs can be mapped to another public IP. That is nothing but the dynamic NAT. Static NAT is one-to-one mapping. Dynamic NATing is mapping of IP addresses to pool of IP addresses. That is called dynamic NAT. Okay. Any questions on that, guys?
No, sir.
Sir, explain it once again.
When you have multiple employees in your company, instead of pointing all the employees to one public IP, you will create a pool of public IPs and you will load share the traffic between both the public IPs. You will create a pool and you will map this one first group to the first public IP and the second group to the another public IP. So it can randomly choose one of the public IP in the pool. Okay, so that can be done with the dynamic NAT. So static NAT is like you are mapping one IP to another IP. That is what a static NAT is. But here you are having multiple private IPs pointing to a group. Inside the group, there can be a public IP1, public IP2. It can randomly choose one, or you can statically map one group to the one public IP.
Good, sir. Thank you.
Okay. So what if we don't have money to buy multiple public IPs? Public IPs are expensive. You cannot, easily buy them. They are expensive, right? You have to spend more money to get more than one public IP. It will cost you $25 per IP. Okay, it's not easy. So in that case, if you wanted to do something like just with one public IP, there's a concept called PAT, port address translation. So let's say you have 100 users. Again, you have a roofing company, just like earlier example. You have 100 employees. But you have only budget to buy one public IP. Okay, on your router, you have only one public IP. It will go to the internet. So let's say this user is trying to go to the google.com. Okay, in the internet is trying to go to google.com. Okay, let's say this user is going to the public IP and trying to go to the google.com. And let's say the next user is trying to go to another website. Let's say they are trying to go to yahoo.com. Okay. So let's say the user IP1 is user IP, or you can say source user1 IP is 10.0.0.1. They are trying to go to google.com, which can be called as 8.8.8.8. Okay, and then we have source user IP2 10.0.0.2. They are trying to go to yahoo.com. Let's say the IP address of yahoo.com is 9.9.9.9. Okay. So the source IP of 10.0.0.1 is pointing to the public IP. Let's say our public IP is 38.38.38.38. So now it's translated to 38.38.38.38. It's pointed to 8.8.8.8. Okay. Okay. Now The source user 38.30, the source user 2 is translated to 38.38.38. It's trying to go to 9.9.9.9. Okay, so response is coming from google.com 8.8.8 to 38.38.38.38 because the source is translated to this IP. Yahoo.com is also replying back to 38.38.38.38. Now, how does the router know who is trying to go to Google and who is trying to go to Yahoo? So based on the source IP, it does know that, okay, I got the request from the 10.0.0.1. Now that IP will be pointing back to this. The request will be pointing back to the source IP1. Okay, the IP address is 10.0.0.2. The router will point back to this response. So this is okay when they are trying to go to different destinations. But what happens when user 1 and user 2, they both try to go to google.com? Then user 1 is going to 38. User 1 is translated to 38.38.38.38 to this destination, and user 2 10.0.0.2 will be translated to the same destination. So now, how does Google know whether they are? How does the router know whether the user 1 or user 2? That will be done using the port. So user 1 will be using one specific source port. Okay. And user 2 will be using another specific source port. So let's draw a table to get better understanding about this. Okay, so let's write a small table. Okay. Okay, so let's write it down. So source IP, the original source IP, origin source IP, that can be called as 10.0.0.1. The second one is 10.0.0.2. Okay, so that is that. And then the original destination is 8.8.8.8. Even user 2 is also going to 8.8.8.8. Okay, translated source IP, 38.38.38.38. Translated source IP 38.38.38.38. Source port, okay, original source port. Okay, that will be, let's say this IP picked original source port like 1025, and let's say this picked 1026. The translated source port, that will be, let's say 2045. This one is 2046. Okay, so now let's pick one color. Let's say user 1, which is this guy, he went to google.com with this destination IP. This guy will be translated to 38.38 this IP, but he is using the original port as 1024. It is mapped to an IP address of 2045. So when the Google is responding back, it is coming to 38.38.38.38, but with the port of 2045. So that 2045 will be pointed to this IP with 10.0.0.1 with the port of 1045. Similarly, when the Google.com is responding back to router 2 on 2046 port, that 2046 port, that will be mapped to user 2. And that is 10.0.0.2 with a port of 1046. So based on the port information, the reverse traffic can be mapped with having only one public IP, and that is called port address translation, which can be helped to reduce the number of NAT IPs that can be used in the network. Any questions on this topic?
Sir, I think there are 1025 and 1026. Like, but you have mentioned 1045 and 1046.
Yeah, sorry. Yeah, 1025 and 1026. You're right. Good catch. Yes. But did you guys got the concept?
Sir.
Any questions, guys?
So, sir, like the original S port is the port which is translated between the system and the router, and the translated is the port. Translation port is the port that which is translated between the router and the internet or the web server. Is that one, or why do we use the translated SP?
If we don't use a translated port, how does the router know which port is the destination to go to? Let's say you are sending a port information of the source port to the router, and this router should map to the public IP, right? If you don't pick a public IP, if you don't pick a public port, how does this will make a connection to this destination? There have to be a specific source port to make a call to the destination port, right? There have to be ports that need to be make the connection.
Yes, yeah, okay.
So that's why they use it. It can use the same port as well. It can use the same port, but it should be unique port so that it can keep track of the connection.
Yes, sir.
So
Correct.
usually there is a reserved ports 1024 to 65535. These are the source ports that are used. So 65535 is the source ports, and from 1 to 1023 are the destination ports. These are reserved by the internet computer systems. So this is the destination ports range. This is the source ports range. Okay. That's about NAT, guys. Any questions about network address translation, static NAT, dynamic NAT? PAT, static NAT is translating one private IP to one public IP. It is a one-to-one mapping. Dynamic NAT is private IP addresses are mapped to pool of public IP addresses, which are in groups. PAT is a port address translation where you will use one public IP for all the internal private IPs, but a different port will be assigned for each private IP address. This is the concept of PAT. Any questions? Okay. If you don't have any questions, thanks for joining today. I will talk to you guys tomorrow.